Our study this time is on mode as part of measures of central tendency. So I want us to say something about this because it is also relevant in biostatistics. So basically, the most commonly occurring value or entry in a set is what we call mode, or what gives us the model value for that kind of data. If two values occur with the same frequency, the set is said to be bimodal, etc. Now for group data, the approach of finding the mode is basically by first inspecting the whole set and tallying the occurrences for every entry. Select the entry with the highest tally, and that will give us the mode. For example, in a set given here as a point, you can see 3 is the most occurring entry of this set. That simply gives us the mode of the set to be 3. Now, it becomes more complex when you are dealing with grouped data. So we have a formula that is used to arrive at this. So the formula below can be applied to estimate the model value in a grouped data. L here represents the lower boundary of the model class, that is the class with the highest frequency. A here represents the difference between the highest frequency and the frequency of the preceding class. That's the class just before the model class. Then B here is actually the value highest frequency minus the frequency of the succeeding class. And C is class interval. Now, this is better explained when we use an example. So we are given data here, and we are supposed to determine the mode of the data. So this is grouped data. So you want to go straight to application of the formula we just talked about earlier. So from this data, you can find the highest frequency here falls at 14. So this 14 defines to us the model class. So we go and find L, which is supposed to be the lower class boundary of the model class. So if I have 25, 26 here, the difference is 1. If you subtract 0.5, which is half of 1 from 26, you get 25.5, which is here, plus, in bracket, I said A is the difference between the highest frequency and the frequency of preceding class. So that's why we have 14 minus 7. And the same A is found here, so we still have 14 minus 7. But there's this other part which we talked about as B. B is 14 minus 8, the frequency of the succeeding class. So this is what we have here. Then you multiply by the class interval, which in this case is 5. If you look at what we have from the lower boundary to the highest boundary, that will give us class interval. Doing this calculation and adding it to this, we end up with 28.19 as the estimated mode of this group data. It is that simple, and we need to understand. Now graphically, someone would ask to be explained to on how we can find mode using graphical methods. So these are supposed to be obtained. So for grouped data, you need to draw a histogram from the data, locate the highest histogram, join the top corners of the adjacent histograms to those of the highest histogram such that the joining lines intersect. It may be difficult to understand this point here, but when we show an example, it will be easier and quick to understand. Then you trace the intersection to the x-axis to get the mode. So this is basically what is in this example here. So in other words, in this example given already drawn, I would not want to go to the process of drawing a histogram and all that, because it is also explained in another lecture. So we have this drawn. You see, these are the upper limits for this given data, and these are number of students, which are actually indicating frequencies, and it's in increasing order, therefore that simply means this is cumulative. So we end up having this bars, connected bars drawn here. So we have this as the highest. So what we said in the other point is simply to draw a line connecting this corner here to this corner here. Yeah. Then the same thing to this other one, the bars that are just next to the highest bar. So we have this here connecting to this, and then the point where they intersect is A. Trace that up to the x-axis, and the value you will obtain here is supposed to be giving us the mode. So as I have said here, that value P is 44.12 for this data, and we can conveniently draw histogram using Excel. That is for another day, and our next study will be on measures of dispersion, which is also very important in biostatistics or any other statistics course. Thank you.